So a shield, an Arduino shield, is basically a printed circuit board, an extra board that you connect to your Arduino to extend its functionality in some way. So the Arduino, if you look at it all by itself without the shield, the hardware is pretty limited. It's got a microcontroller. It's got pins, holes that you can connect to the pins of the microcontroller. It's got an LED on there, right? And then there's a USB port that's used to communicate with the computer. But besides that, it doesn't have much in the way of interface. So it would be nice. It would be nice. It is necessary in a more complicated system to extend it to do certain things that you can't just do with the Arduino, the microcontroller alone. So a shield makes that easy for you. A shield, it's basically two things really. It's hardware, which is a little board, a printed circuit board, which is basically the same size as the Arduino and fits right on top of the Arduino. And it's sold, it's a pre-wired, pre-manufactured board, and you can buy it manufactured. You can also, there are actually also shields that are not manufactured, where you can just buy the design. It's open source. You can buy the design, you can manufacture it yourself, but generally, you're going to buy it pre-manufactured. So there's the hardware side of the shield, but there's also the software side, the library, the library that's associated with the shield. So, to make it easy, we talked about libraries. To make it easy to use these shields, that you're provided with some kind of a library with a set of functions that do all of the interesting things that the shield can do. Benefits of shield. So why do you use a shield? No wiring is needed, right? You don't. So there's a picture of a shield. That's an Ethernet shield right there, which actually we'll use that in a future lecture. The circuit on that shield is pre-wired. So if you look at that shield, it's got several components on there, chips and things like this, all wired together. That wiring you as a user did not have to do. That wiring is given to you. It's all pre-wired. So you don't have to worry about the details of the wiring, which can be hard. Also, the wiring that connects the shield, all the shield pins, to the actual Arduino pins, you don't have to worry about that either, because that's done for you automatically by stacking the shield on top of the Arduino. So if you look at the shield, it's got pins underneath it, which fit into the holes of the Arduino. So you don't have to do any kind of wiring. You just take this board, stack it right on top of the Arduino, and everything, all the wiring is done for you. So that's a great thing, right? You don't have to design the hardware side of the circuit at all. Simple to use because the library functions take care of all the complicated details of how to use the device. Like in this one, this is an Ethernet controller. And there's a chip in there it's like a WizNet Ethernet controller chip, if I remember the name. And that's a kind of a complicated chip to use. I've used that chip separately. There's a data sheet, a thick data sheet, and you have to understand it. With these functions, with these library functions, you don't have to understand any of that. You just call them and ta-da, you've got an Ethernet connection. Pins. So the picture is actually a shield without the pins attached. Okay. So the pins on the bottom. So if you look at the Arduino, it's got a set of holes, rows of holes on the top and the bottom, or left and right, depending on your orientation. That are the pins. So these shields have pins underneath them that go right into, that line up with the holes on top of the Arduino. So you can take the shield and stack it right in there, and the wiring is automatically done. So most shields only use a small subset of the pins. Even though all the pins are wired, so you stack and you connect to all the pins, most of the pins are not used to communicate between the Arduino and the shield. And this is important because if you have multiple shields, say I'm using two shields, I'm stacking two. If they're using the same pins for two different purposes, then the communication will fail. So say, one shield is using digital input 1, digital pin 1 for an input, the other shield is using digital pin 1 for an output, then you got a problem. So when you're using multiple shields together, you need to be aware of what pins are being used for what shield and how they're being used. Now, a common way for shields to communicate with the Arduino is through I2C, which we learned about using the wire library, right? You can use the wire library to access that. That sharing is fine, right? If you got three shields and they all communicate through I2C, they can share exactly the same pins, the SDA and SCL pins, and there's no conflict, right? As long as each shield has a different address, a different slave address, no conflict. You can stack as many as you want, as we just learned about when we were talking about I2C. But other times, the two different shields can use the same pin for two different purposes, and there can be a conflict. So shield headers may not be soldered in. So sometimes when you get a shield, it's not fully manufactured. Like the one we see in this picture right here, you got the shield, but it doesn't have its header pins soldered in. So you'll see along the sides, it has holes. It does not have actual pins underneath. Just next to the shield are the headers, what are called the headers. Those are the pins that you're going to solder in. So you would have to solder those in. You'd have to stick them through the holes and then solder them in. We're not going to actually cover that in this class. So I'll recommend that for this class you buy shields that are pre-manufactured fully and you don't have to do soldering. Although soldering is a useful thing, but we're not covering it. Thank you.